YouTube. So hello guys, welcome to my channel. Anyway, instead of me spending $2,000, $3,000 buying a milling machine, I decided to build my own one. So here's the breakdown. So I'm using 23s, 4 25-ounce motors, long double shaft, a 300mm Z-axis rail with our HR20, and this is my Spindle 2.2 kilohertz, 110 volts with the Chinese CFD, which is not bad. I bought it at Amazon, both for $323. And this is my vise I also bought on Amazon, a 4-inch vise. I only paid $89 for this guy. And so I put all this together. The Z-axis I built myself. I used these other plates to lift it a little higher so it can actually meet up with the bottom. The small tiny wood you see here, it has a depth or lift on this side about 2 to 3 mils. So what I did was put this little piece of wood here just to even it out, to get a even contact with the bed to the surface of the item that I'm cutting. And the reason why that's there is because I think that this bottom plate, where everything is sewn at one side is higher than the other, I think the plate was cut wrong. So eventually I'm gonna redo this again with another plate like that I did here to the top y-axis. This is a 1/4-inch plate aluminum that's holding the vise. So I'm gonna take the same amount of size and I'm gonna put it down here to give it a better support, and then I could actually remove this and it'll be more level. Right now it's level with me putting this piece of wood here, and it's cutting fine. So soon we'll be jumping to the cut so you can see how smooth in the cut. This is my first cut I did on this homemade milling machine. Surface cut. We already did one. We're gonna do the second one to see how it turns out, and you can see how everything works out. A lot of chips. Okay. So as you can see, nice and smooth. Let's release it. And yeah, for a homemade machine, that is not bad. Nice and clean. Yeah, I'm trying to get you guys to see a little better. So let's see here. Yeah. Nice and clean. Did the back side already earlier, so you can see the nice and smoothness. Sorry, I got a cold. Yeah, nice cut. You know? Nice and surface. Let's see what it looks on the surface, if there's any empty spaces in between. So let's get the camera closer in there. And so there's no gap. Yeah, there you go. No gap whatsoever. Try the other side. Yeah. There might be a little tiny gap here, but not bad. The other side, because I ran it twice, so that's why it's more even. But that surface is nice and clean. Yeah. Yeah, nice and clean. So this is the final cut of the outcome of that homemade milling machine. So let's get some measuring here to see if it's accurate. Okay, so we're gonna start. As you can see, the smoothness of the cut. You can see it nice and clean there. Nice. Get the other side. It got a little rigid over here, and I think that was the first run. And this is actually the first run on this side. I haven't run this side yet. I only ran this side, so we're going to be measuring from this side to see if it's even on both sides. Yeah, so this side got the 2 runs on it. I took off about 6 mil, maybe 5 mil over it. So let's see what the measurements are from. Make sure we got, this is the rigid side that I didn't cut. This is the top. So we're gonna go from here to here and see if it's an accurate reading. So 41.88. Let's go to the center. 41.28. That's not bad. I'll come to the end here, and 41.77. We'll flip it over and make sure that we do not have the rigid side. Okay. And let's see what we get here on this side. Let's start from the top here, and 41.84. Go to the center. 41.53. I think that's me moving. Try again. One time. Yep. 41.85. That's accurate. And we'll try the end here and 41.85. That's not bad. And this is on the first run. Like I said. So this guy here, I ran this guy twice. That's why it's nice and smooth. As you can see it. On the other side I only ran, actually this is a smooth size, sorry about that. So you can see that it actually did run nice and clean from the cut. And then this side it will be, this is a smooth side here on this side. I ran this once and then moved over, and I got it rigid here in the middle for some reason. I guess it was excuse me. And one part on this side was kind of a little high. So when I did my 5 mil cut, there is a small, yes, tiny lift here. So some left over from this side. So I'm gonna run this in one more time to even it out. But yeah, this is from the one that like I said, I built this milling machine instead of me spending $2,000 to get one. And this is my little one that I got to do small projects. And soon I'll be coming to let you guys know about this review of the 4030 that I got on Amazon for $9.99 from Smart Smart or something like that. Trying to remember the company that I bought it from. But anyway, yeah, this is an amazing CNC, well put together. I just love the way the 2 stepper motors on the back, they work together as one, like the high professional ones. There are lead screws in there that drives them. There's one on that side, and there's one, sorry for the sun, there's the other one there. So this is my air pocket to pick up my dust. Soon I'll be doing a review on this, and I'll give you guys a heads up. This is the equipment here, and that is the computer I'm using. Anyway, thanks for watching my video. If you have any comments on this homemade milling machine, let me know, people, because I put it together, and today was my first cut after finished doing all the touch-ups, and it cut nice and smooth and no problems whatsoever. Now I just gotta just get some kind of vacuum cup for it. Perry put some some fiberglass box around it so that all these chips was fall in one place and not falling all over the down here where the rails at and the lead screws at. Get the lead screw all dirty. When I do cut, this gets filled up with chips, so I'm trying to see if I could get the skirt to cover this. This whole project cost me let me see, $328 for the spindle and the VDF, $80 for the 3-stepper motors, everything else I have from an old machine that I took apart. I put this the X-axis myself together, $70. I say my total spend on here was about close to $800, better than spending $2,000 and not get a real spindle. Get one of those, they give you those motors on those milling machine that they run at like I think it's 2,500 RPMs, and that's it. This is 1,800 RPMs. I mean, I could run at any speed, cut anything I want with it, and it's perfect. Anyway, if you have any comments, let me know. Give you a thumbs up if you like this video, a thumbs down if you don't. Give me a suggestion. Stay in contact, people. Subscribe to my channel for more and the latest news on custom builds like this. Have a nice.